All right, so I'm going to go through this review. I'm not going over every question, but I'm going over most of them. Just any duplicates I didn't go through for the most part. But I'm going to go through it kind of quickly. If you still have questions, if you watch this video, then just let me know and send me a message on Reminder and we can work them out. All right, so for this one, it says, this is question number 12 on page 279. So I'm doing page 279 first. So a producer plans an outdoor regatta for May 3rd. The cost for regatta is $8,000. This includes advertising, security, printing tickets, entertainment, etc. The producer plans to make $15,000 profit. So that means after he spent this $8,000 for the cost, he's making $15,000 above that for profit, if all goes well. However, if it rains, the regatta will have to be canceled. According to the weather report, the probability of rain is 0.3. Find a producer's expected profit. So what we need to do with this is we need to figure out what are the outcomes. What can happen? It can either rain and he loses the $8,000, or it doesn't rain and he makes $15,000. So those are our two outcomes: is that he can make $15,000 or he can lose $8,000. Nothing else can occur with what we're looking at now, because this is what he expects to make. And if it rains, he loses it all. And then we need to look at the probability of each one happening. Well, it says it's a 30% chance of raining, so that means he has a 0.3 chance of losing the $8,000. And that means if it's a 30% chance of raining, that means it's a 70% chance that it won't rain. And then if we want to find our expected value, we just go ahead and we multiply and find the mean. So 15,000 times 0.7 is equal to 10,500. And negative 8,000 times 0.3 is equal to 2,400, so it'll be minus 2,400. And then this will give us an overall expected value of $8,100. So that means on average, he can expect to make $8,100. It doesn't mean that he will make $8,100, because obviously he can only make $15,000, or he can lose $8,000. That's the only possibilities. But what this $8,100 is saying is that if he were to do this concert infinitely many times, in which each time there's a 30% chance of rain, on average he would make $8,100. So it would not rain a bunch of times where he would make $15,000, then it would rain a bunch of times where he would lose $8,000. And then when he added up all his profit and all his losses and averaged them together, he would have on average $8,100. So we're finding the average as if we were to do this infinitely many times. So his expected value, what he can expect to make on average, is $8,100. So since that is positive and it's a fairly large number, then that means that he would have, he should go ahead and go through with this concert, even though there's a chance of rain, because the expected value is pretty high. All right, so for this problem, it says pizza for breakfast. 3 out of 4 American adults under the age 35 have eaten pizza for breakfast. If a random sample of 20 adults under the age 35 is selected, find a probability that exactly 16 have eaten pizza for breakfast. Now, what tells me I'm using this formula now is that it gives me a finite number of people. We're only looking at a random sample of 20 adults under the age of 35. Right? We're not looking at infinitely many like we were when we were solving this problem. This problem, it doesn't say that we're going to do this concert 10 times or for 1 month. We're acting as if it's going on forever. So they never gave us a finite number that what will happen if we do it 16 times. So unlike this problem that we're just working on or going to start working on, this one gives us a finite number, 20 adults. That's it. We're only having a sample of 20. So that tells me that I am going to go ahead and use the formula of the NCR, or I guess I should write NCX, times the probability of P raised to the X power times Q, so the failure probability, raised to the M minus X, so the number of failures that we have. Because this N tells us we're using a total amount, a finite number. We're not looking at it as if we're doing it infinitely many times. So then we need to go ahead and solve for these variables. So N is a total number, so we're looking at a random sample of 20, so that means we're picking 20 people randomly. And X is however many successes we want, so we want 16 people to have eaten pizza for breakfast, so that means X is 16. So P is the probability of X happening. Well, 3 out of 4 American adults under the age of 35 have eaten pizza for breakfast, so that means the probability is 0.75. And Q is the probability of failure. So that would then be 1 minus 0.75, which is then equal to 0.25. And then we just plug it into this formula. So it's 20 NCR 16 times 0.75 raised to the 16th power times 0.25 raised to the 4th power, because 20 minus 16 is 4. We would put this into our calculator and it will give us 0.19 or 19%. So what this is saying is that if we were going to take all of the people in America and we said we're only going to select 20 of them at random, that we have a 19% chance of having 16 of those 20 to have eaten pizza for breakfast. Right? So this is telling us what we can expect to have. What is the probability of actually having this as part of our random sample? Right? And we would have a 19% chance for that. All right, so now we're going on to page 281, number 11 and number 12. The directions for this say, determine if the distribution represents a probability distribution. If not, state why. So there are 3 rules that we have in order to help us determine if this can be a probability distribution. It doesn't really matter the order in which you go through it. The first one is probability cannot be less than 0. So no negative numbers. The probability of X, so each individual probability of X cannot be greater than 1. Because as we've learned before, the probability of an event happening can only be between 0 and 1. So we can never have one individual probability be more than 1, and we can never have one individual probability be less than 0, or it's impossible. And then the probability of X, so the entire row, must add to 1. So if any one of these fail, then it fails, period. So for number 11, none of these are greater than 1 and none of these are less than 0. So although it solves both of those, 1 plus 2 is 3, plus 2 is 5, plus 3 is 8, and plus 2 is 10. So that will be 10 over 7, which is greater than 1 and not 1. So it fails number 3. So this is no, it is not, and it adds more than 1. Right? So for the next one, here they're all less than, or they're all greater than 0 because they cannot be less than 0. So probability of X is greater than or equal to 0. Probability of X is less than or equal to 1, same exact thing, which they are. None of them are greater than 1. And then here, 0.3 plus 0.5 is 0.8. This will give me 0.1. And 0.8 plus 0.1 plus 0.1 is equal to 1. So this one satisfies all, so this answer is yes. All right, so for number 16, it asks us to construct a probability distribution and draw a graph for the data. So the first thing that we have to do when we're asked to construct a probability distribution and draw is we need to go ahead and create our table. And it is our outcomes of X, and it is our probability of X. So we have 0, 1, 2, 3, and 4. Well, when we add up all of our frequencies, it adds up to 100. So that means each of these we will put over 100. 2 out of 100, 30 out of 100, 48 out of 100, 13 out of 100, and 7 out of 100 in order to identify the probability of it happening. So the probability of 2 out of 100 is 0.02. The probability of 30 out of 100 is 0.3, then 0.48, then 0.13, and then 0.07. All right, so then we want to create a graph. So we want to draw a graph. So here we would have 0, 1, 2, 3, 4. Remember, this isn't necessarily our X and Y axis as far as that this intersection represents our origin of 0, 0. But we use a graph like an X and Y axis to put our outcomes on our X and our frequency or our probability on our Y. So here I'm going to count by 0.1, so it'll be because I only need to go up to 0.5, so make it easy for yourself, 0.1, 0.2, 0.3, 0.4, and 0.5. So this is 0.1, 0.2, 0.3, 0.4, 0.5. This one may be a little bit tricky because 0.02 and 0.07 may be hard to approximate. I would have done with 0.5s personally, but I didn't have enough space for it. But 0.2, so we just go to 0, and we're at 0.2, so I'll say that is approximately right there. So there's our graph at 0.02. 0.3 for 1, we're just drawing like a straight line. 2 is 0.48, so 0.48 will be there. 3 is at 0.13, so it's slightly above. And 4 is at 0.07, so slightly below. And there is our graph. Right? It's actually pretty easy. We just take each frequency and divide it by the total number in order to identify the probability. And then our probability is our y, and our outcome is our x, and we create our graph. And it's nice and easy. All we have to do is pretty much just draw those straight lines. All right, so for this one, there's really not much I can show you on the actual video because you're just going to plug this into your calculator. All right, just remember though, if you're using your graphing calculator, you will press Stat, then you will go to Edit, and in your list 1, you will put your outcomes or number, and in your list 2, you will put your probability. Then you will click Stat again. You will scroll over to Calculate. Then you will click One Variable Test. Then you will go ahead and put for your list, it will be your outcomes, so it'll be your L1. For your frequency, it'll be your probability, so it'll be L2. And then this will give you your mean. Let me put this somewhere else. Use a different color. This will give you that your mean is equal to 2.02, but remember we always round one number less. So we will then go ahead and do 2.0. On your test, I don't really care, to be honest. As long as you get the right number, that's fine. Then here we would have our standard deviation is 1.12, so it will round to 1.1. And then to find our variance, we just square our standard deviation, which will square to 1.26. So then it rounds to 1.3. Right, so these are the 3 answers that you should have gotten when using your calculator. Scientific calculators can do this as well. So if you need help with that, just let me know, or you need help with this, just let me know. All right, so this one says a person selects a card from an ordinary deck of cards. If it is a black card, she wins $2. If it's a red card between or including 3 and 7, she wins $10. If it's a red face card, she wins $25. And if it's a blackjack, she wins $100. Find the expectation of the game. So once you see it says expectation, that means we need to find the mean or the average. And it's also not telling us that she's doing it 10 times. It's just saying in general. So that tells us that we're not going to use a formula with our NCX or NCR. So we're going to have to create a table. Whoops, that's an awful line. So we're going to have to create a table where we have our outcomes and we have the probability of the outcomes. So the outcomes is that she could win $2. So she wins $2. And that happens if it is a black card. So if it's a black card, there's a 26 black cards in a deck of cards, so it's 26 out of 52. If it's a red card between 3 and 7, she wins $10. So one of the outcomes is that she can win $10. And a red card between 3 and 7, so that's 3, 4, 5, 6, and 7, or 1, 2, 3, 4, 5 different cards. And there's 2 of each for red, so it'll be 2 times 5, or that means there's a 10 out of 52 chance of getting a red card between 3 and 7. And then this will reduce to 5 out of 26. So there's a 5 out of 26 chance of her getting a red card between 3 and 7. She gets $10. I'm sorry, if it's a red face card, she wins $25. Red face cards are Jack, Queen, and King. So there's 3 of each, 3 of those, and there's 2 of each when we have red, so that means there's 6. 6 out of 52, each are divisible by 2, so it's 3 out of 26 chance of winning the 25. And then if it is a blackjack, then she gets an extra 100. So she would win 100 if it's blackjack, and there's 2 blackjacks, so 2 out of 52 reduces to 1 out of 26. All right, you could plug this in your calculator, but since it's not that much, we can just multiply. So we'd multiply each one, and we'd add them together. And if you want to use a calculator, by all means, you don't have to do this by hand. I just think that it takes just as long typing it in as it would using a calculator. So this will then be 1.92. This will then be 2.88. And this one will then be 3.85. And when we add them together, she could expect to win, on average, $9.65. So It doesn't mean that she will win $9.65 because that's not actually one of the options. It just means if she were to keep doing this game infinitely many times, on average, she can expect $9.65. And also another thing you can say is if she were to win the 100 or the 25 or the 10, you could say that she's actually earning more money than the expected value. She did better than what we thought she should have or could have done. All right, this one says if 40% of all commuters ride to work in carpools, find a probability that if 8 workers are selected, 5 will ride in carpool. So this tells us a finite number. It says if 8 workers are selected. So when that happens, that means we are going to use our NCX. So our formula will be NCX times the probability of the success raised to the number of successful events that occurred times the probability of failure raised to the number of failures. So we need to identify what is our N equal to, what is our X equal to, what is our P equal to, and what is our Q equal to. So N is the total. Well, we have 8 total people. It's because we're picking, we have a sample of 8. 5 is the number of people that will ride in a carpool. So that's the successful selection. So there's 5 will be X. And it says 40% of all commuters ride in carpool. So that means the odds of someone riding in a carpool or the probability of X happening is 0.4. And then the probability of X not occurring will be 1 minus 0.4 or 0.6. Then we just plug it into our calculator. So it'll be 8 NCR 5 times 0.4 raised to the 5 times Q raised to the M minus X. So 8 minus 5 is then going to be equal to 3. We plug this into our calculator. Sorry, this should be not Q. Our Q we know is 0.6, sorry. And this will then be equal to 0.12 or 12%. So there's a 12% chance that if we were to select 8 people at random out of all this population in the U.S., that 5 of those 8 people would commute in a carpool. And it kind of makes sense because they're saying that out of all the population, only 40% ride in carpools. And we're trying to figure out what are the odds that 5 of the 8 would ride in carpools, and 5 divided by 8 is about 63%. So that means we're trying to have and hope that there are more people than what is actually in our population, like more people in this random sample of 8 than there would be in our population as a higher percentage. So that means it shouldn't really be very high because 63% does not accurately represent what the actual population has. And these numbers should be fairly close to each other, or it's not accurately representing our information or our data with our country. All right, I'm not going to do A for this one because that's exactly what we just did the last one. When it's an exactly amount, it's actually really easy. All we need to do is just find the NCX, in which our N is equal to the total number and the X is equal to the exact amount. So we're not going to solve for A. We're only going to do B and C. All right, so it says if 60% of all women are employed outside the home, find a probability that in the sample of 20 women, that at least 10 are employed, or at most 5 are not employed outside the home. So what we need to do is first identify. It tells us that we only have a sample of 20, so that tells us that we're using a finite number. That lets me know I'm using my NCX. So for B, we will have to identify what is our N, what is our X, what is our P, and what is our Q. So our N in this case is 20, and it's going to be 20 for no matter which one we do of these because that's not changing. What's changing is the successful number of trips. So it says at least 10. So at least 10 means 10 is the less it can be. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So that means we're actually going to have to do, and I'm not going to go through it for all of them, but you would actually have to do all of those cases. And the probability of the event happening where they're worked outside the home, that's 0.6. The probability of a failure is 0.4. So what we would have to do is we would have to do 20 NCR and then 10 times 0.6 raised to the 10 power times 0.4 raised to the 10 because 20 minus 10. And then we would have to do 20 NCR 11 times 0.6 raised to the 11 times 0.4 raised to the 9. And then it would be 20 NCR 12 times 0.6 raised to the 12 times 0.4 raised to the 8. 20 NCR 13 times 0.6 raised to the 13 times 0.4 raised to the 7. And we would have to continue this until we got to 20 NCR 20 times 0.6 to the 20 times 0.4 to the 0. We would calculate all those individually, then we would add up each one. So not only will we have to calculate them, but we would add them up, and that would be 0.872 or roughly 87%. So that means if we have a sample of 20 women out of all the women in the US or whatever country this is that work outside of home, that we could have an 87% chance that that sample will include anywhere from 10, 11, 12, 13, 14 to 20. So we have an 87% chance that we would pick 10 or more of those women would be working outside the home. I know that this problem would have been a really long one, and I know I skipped it, but on a test it won't be that long. It'll be much shorter than that. All right, now let's go ahead and do C. I actually have to pause this video and do a separate one for this because if you see, sometimes my this app that I use, this notebook, sometimes it like freezes or it doesn't really work properly, and you see it's not letting me erase and it's staying in a screen no matter how I move it. So I'm gonna have to end the video here and then restart it and then start a new one.